Thank you. Okay, cool. Yeah, so I'm going to be talking about energy, but I thought probably just start with talking about fossil fuels and like the problem around fossil fuels. So most of you are probably aware fossil fuels are created from decomposing animals and plants, and that's taken from the crust of the earth. And then, so whatever fossil fuel that's taken, so coal, oil, natural gas, is then burnt to create energy. So all fossil fuels release hydrogen and carbon. So when it is burned, it's released into the atmosphere. And then obviously the increase in carbon in the atmosphere is what's causing climate change, and is ultimately why fossil fuels are a problem. So fossil fuels are responsible for about 3/4 of the emissions from human activity. So that doesn't just include like energy creation. Obviously fossil fuels are used for other things as well. But in the UK, domestic energy usage is the second biggest consumer of energy in the UK. And it sort of looks like that's going to rise and overtake the number one spot, which is currently transport. Yeah, so there's a big reliance of fossil fuels all around the world, and it's not a problem that's going to be solved overnight. However, if you consider your own domestic energy usage, it is a good way to make a change. Next slide, please. Thank you. Okay, so with the changing in climate, we're obviously going to be, or I imagine we'll be using more heating in the winter, possibly we'll need air conditioning in the summer. And we also, I guess, are having more of a reliance on technology, which isn't necessarily a bad thing, but it does mean that our electricity consumption is going to increase, which then would overall just mean there'll be an increase in carbon in the atmosphere unless we make like changes ourselves and obviously have like bigger changes within the energy industry. But if we consider how much energy a household uses, so according to Ofgem, the average British household uses about 12,000 kilowatt hours of gas and 2,900 kilowatt hours of electricity a year. So in terms of carbon, the 12,000 kilowatt hours of gas equals about 2,198 kilograms of CO2, and that is apparently equivalent to 7 transatlantic flights or 13 car journeys from Land's End to John O'Groats. So, I mean, to me, that seems like quite a big figure. Just thinking, if someone told me they took 7 transatlantic flights in a year, I would think, wow, that's a huge amount of carbon they've sort of contributed to the atmosphere, but we're all sort of doing it in our day-to-day lives. And then if you multiply that by the amount of properties in the UK that are on gas, that is going to be a huge amount released into the atmosphere that obviously we can't avoid because we need to use gas for our heating, but could possibly be reduced if we had more efficient homes and reduced our reliance on gas. And then also in terms of electricity, it's probably a bit harder to determine the carbon footprint of that, because obviously it depends on your source of electricity, but that is also going to have an impact as well. So hopefully, yeah, that shows you a little bit that our domestic energy usage does have an impact towards the environment and towards climate change. Next slide, please. So I just wanted to mention as well an issue which is pretty current in the UK, and that is the lack of proper insulation in a lot of our homes and the heating loss that is caused due to the lack of insulation. So a study done in 2020 by a company called Tado, I think they make like smart thermostats. They use smart thermostats in 80,000 homes across Europe, and they measured how quickly those homes in different countries cooled once the heating was turned off. So in all of the houses, the starting temperature was 20 degrees, and then the outside temperature was 0 degrees. They turned the heating off, and then within 5 hours, the temperature dropped by 3 degrees on average in a British home. And then if you compare that to Germany, where it only dropped 1 degree, or in Italy, 1.5 degrees, that I think does show you the average household maybe isn't as insulated as well insulated as it could be. And it is just one study, but I think there is other research out there that suggests similar things. And if you maybe talk to people about their own properties, you'd find that a lot of people have the same issues. And then if you take a look at the graphic, the mapping out heat loss, it shows you where most of that heat loss is going to be coming from. So that is going to be from the roof and from the walls. So obviously, wall insulation and loft insulation are really important to having an energy efficient home. And then just to touch on like energy efficiency and energy performance certificates, according to the government, the average EPC rating of properties in England and Wales is a D. So if you're not sure what an EPC is, it's basically a certificate that tells you how efficient the property is. And the ratings go from A, being the best, to G, which is the worst. When a property is sold or rented out, it has to have an EPC. So if you aren't sure what yours is, you most likely will find it on the government website. Yeah, you just go on the website and search it, and it will ask you your postcode, and you'll be able to find the EPC. The only situation where you might not have one is if you have lived in the property for quite a long time, then it's probably expired and might not be up there anymore. So the EPC also breaks down sort of what aspects of your property are maybe rated good and what's rated poor. So if there's wall insulation, cavity wall insulation, that'd probably be rated good. Or if you had really old and inefficient storage heaters, that would be rated poor. And all of that sort of comes up with a score that leads to your energy performance rating. But EPCs are quite helpful in that they do also make some suggestions for improvements that can be done on the property. It will estimate like the cost of it, of like the work to actually be done, and then the financial and carbon savings. So if you were thinking about maybe making any improvements on your property, that might be a good place to start to know what sort of would have the most benefit for whatever sort of your target is, whether you want reduced energy bills or reduce your carbon footprint. Although I guess the two go hand in hand. Next slide, please, Karen. Thank you. Okay, so yeah, so what can you actually do at home to reduce your carbon impact and also save on your energy bills, which I'm sure, as Karen mentioned, everyone is sort of wanting to try and do as well. So I've just used this graph from the Energy Saving Trust. They're a really good website. They have loads of resources about everything to do with energy. So if there was something you were interested in, they most likely would have information on that website of where you can, like who you can talk to or what they recommend, things like that. It's definitely worth having a look at that. But if we just go through the graph, you can see that having smart heating controls has the biggest potential saving cost per year. I think it's at £70 a year. So yeah, that's definitely potential. That's not going to be the same for everyone because it really depends on how you control your heating already. But with smart heating controls, it sort of easily allows you to check what temperature your property is, change it when you need to. Maybe you've left the house and you forgot to turn the heating off. You can do it from your phone. They also learn like your habits, what you sort of do every day, and then it can adjust like the temperature and controls as it learns more about your habits. So for example, if you have like a shower at a specific time every day, it will figure that out and have the hot water ready for you when you're going to most likely be going in the shower. And then it can also detect things like if you've opened a window because you're too hot, the temperature will obviously drop, so then the thermostat will adjust to bring the temperature down as well. So yeah, that smart technology is sort of what is going to be bringing your bills down and hopefully bring your actual energy usage down. So then the second one, I think, is turning your thermostat down. So that should be turning your thermostat down by 1 degree, saves on average about £55 a year. So the recommended in terms of health to have your home at is between 19 and 21 degrees. And yeah, that's recommended for health. Obviously, everyone is different. Maybe if you're more vulnerable to the cold, you might have it higher. Some people at PECT have it a lot lower because they just would rather spend their money on something else and just wear loads of layers, which is totally fine as well. But if you do have it at like the 21 degrees, you might want to try it at the 20 or 19 degrees, see if you're still comfortable. And if you are, you could keep it at that. And that would hopefully reduce your energy usage, like whatever you have for heating, and then also have a positive impact on your bills. Let's see what else is on there. Oh yeah, switching off things on standby is also quite a big one that maybe not everyone does or is in the habit of doing. So obviously when you have your TV on standby, it still usually has like the little red lights on. So it's still going to be using electricity. It might not be huge amounts, but it's still about £30, I think that says, a year, that's a good saving just for one small action. And the same thing can be done if you have like phone chargers that you just keep on all the time, even when your phone's not plugged into them. That's still going to be using electricity. And the same with any appliance, basically. So just make sure you're turning things off to make sure that that electricity isn't being used through that appliance. And then some of the other ones on there are just really small things that you can try and do. And that graph is quite easy to find on the Energy Saving Trust, so you can look back at it if you need to. So another thing I was going to mention that's not included on there, and is something I've only really recently been aware of, but is to turn your temperature down on your actual boiler. So this is only really recommended if you have a combi boiler, but usually they're set at about 75, 80 degrees. But now the sort of recommendation is that you could actually turn it down to about 50 degrees, or maybe 60 if that's too low, and your hot water and heating should still be sufficient enough, but also have the benefit of decreasing your energy usage and decreasing your energy bills. So that's something maybe to consider. If you have a hot water tank, definitely don't do it though, because you could be at risk of Legionella, sort of like bacterial virus you can get in water that's sort of just sat in those tanks for too long. So this is specifically for combi boilers. And I've also linked a YouTube video from the Heating Hub all about it if you did want to find out more about that. That'll be in the toolkit. Yeah, next slide, please, Karen. Thank you. Okay, so yeah, so that was all just like maybe small habits you could make in your home, like just in your day-to-day energy usage that will add up to small carbon savings and hopefully some savings on your energy bills as well. But there are also like bigger things you can do to your property that you might be interested in that will have maybe a bigger impact and would help with our like reduction on reliance on gas, definitely. So like I mentioned earlier, your EPC is a really good starting point for knowing like what needs to be done in your home. But personally, I would say that insulation is always the first thing to consider, as you don't want to, I guess, put in like a brand new heating system and have all that heat lost out the walls and the roof because it's not well insulated. Sort of doesn't make sense like financially. So with loft insulation, it can be relatively inexpensive to do if you feel like able and safe to do it yourself. So obviously not everyone would be able to do it, and you've got to make sure you're wearing a mask and standing in the right places and stuff. But installing loft insulation in an average semi-detached property can save about 580 kilograms of carbon a year, and £165 on your energy bills. I think those figures are maybe like a couple years outdated, so the saving on your bills might be more due to the increase in prices. But that's a really big saving, especially compared to like all the sort of smaller changes you could do. And the regulation for new builds and loft insulation is for them to have about 270 millimetres of loft insulation, I believe. So if you are like on the lower end of that, it'd definitely be worth topping it up as well. And if you look at an EPC, it does say whether your loft insulation is below or above 200 millimetres. So if it's below the 200 millimetres, then I would say it's definitely worth topping it up. So then, as well as loft insulation, you obviously have wall insulation, but it's not always so easy to do depending on how old your property is. So I think it's if your property was built before the 1960s, you wouldn't have cavity walls and most likely wouldn't have cavity wall insulation. So if your property is newer than that, you could look into cavity wall insulation if you don't already have it. And that's like a pretty simple job for an installer to do. It's just injected through the walls. So it's not like a big job on your house. You don't really have to like overhaul your house, and it doesn't impact the look of the house. But in terms of savings, it can save about 670 kilograms of carbon and about £280 a year on your bills. So I think if you are interested in that and sort of look up the prices of cavity wall insulation, you should hopefully like earn the money back on that quite quickly. And then so with older properties, that would be a bit more of a difficult job. So older properties have just the solid walls, so the insulation either has to be on the outside of the wall or actually inside the home. So it's a bigger job for that cladding to go on. If you're having it done inside the house, you're obviously going to have to like redecorate the house and stuff like that. But it can save about 900 kilograms of carbon a year and about £400 on your energy bills a year on average. So again, it is a pretty big saving, but that's definitely a bigger investment. So maybe it isn't sort of feasible for everybody. Okay, so then if your home is already like quite well insulated, you might be interested in low carbon heating or renewable electricity. So one of the pictures, we've got solar panels, which I think are pretty common nowadays, especially in Peterborough. You see them absolutely everywhere. And similar to the wall insulation, it is quite a big investment that maybe not everyone can afford, but it might be worth it for some people. It basically will allow you to create your own energy or your own electricity, sorry, so that you reduce your need to take any from the national grid. And they also offer, so energy suppliers should offer smart export guarantee or SEG tariffs, which mean that any electricity you produce that goes back into the grid, you can be paid for that. Or you can alternatively invest in a battery and then you can store that electricity that you've created. But I think at the moment there are some issues with like parts for batteries, so that might not be too possible at the moment, but it's definitely something worth looking into. And then with like the SEG tariffs, you can get that for other sources of renewable electricity. So some people might even consider like a wind turbine in their house or something. Obviously, that's going to be totally dependent on where you live in the UK for how appropriate it is. They're a lot less common in the UK, and they possibly wouldn't create enough electricity for your home, but still might be an option that some people want to look into. So that's like the renewable electricity side of things. And I should mention as well, with solar panels, you can get maybe support with paying for those things, or you can do like community purchase schemes where you can, like, if there's a big group of you that all want to buy it, then you might be able to get reduced prices for solar panels and stuff just to make the prices a bit more affordable. And then, so in terms of like low carbon heating, so the two photos on the bottom are of heat pumps. So the one on the left with like the box on the wall is an air source heat pump, and that basically draws in heat from the outside and brings that inside, and that's used to heat the water, which is then used for your heating or like your shower and bath and stuff. So the air source heat pumps are probably the more common form of heat pump, and if you have outdoor space, it should be relatively easy to have it installed. Some people might have to have like their radiators replaced, things like that, but usually it should be like not that big of a job. It is going to be powered by electricity, but obviously it's going to move you away from relying on gas, and so it makes a big difference in terms of your carbon footprint. And then the other image is of ground source heat pumps. So that is basically, these pipes are under the ground and the water moves through those pipes, and the heat under the ground is going to heat up that water, and then that's going to be used for your heating. I think they're a bit less common in houses and possibly a bit less efficient than air source heat pumps, but they might still be recommended for some people, I'm not sure. And so like a common misconception about heat pumps as well is that it might be too cold in the UK for them to work, because obviously it is bringing in the warm air from the outside. Even if it doesn't feel like it's a particularly warm day, it should still be able to bring in the warm air. I think there's sort of like the temperature bracket that heat pumps work best at, and apparently that covers about 95% of the days in the UK, so it should be fine to use. And I know that they are also pretty common in like Scandinavian countries who have like slightly more extreme weather than we do, so I think they're still sort of appropriate in the UK, and look like they're going to be the thing that people do move towards as they move away from gas. But there are like some other investments to look at, but I will leave that because I'm not too much of an expert on the other things. But if you go onto the Energy Saving Trust website, you can look at all the other options for low carbon heating, and that might bring something up that maybe is more suitable for your situation.